All right, today I want to talk about orgdb. It's a tool I use for searching for things in my org files. So last couple of times I talked about the scimax journal and scimax notebook. Those allow me to generate journal entries that now spread over many years, and each one of the notebooks is its own little project of sorts, and they're spread all over the place in Google Drive, in Box, in Dropbox, and on my regular hard drive. And a lot of times I want to be able to jump around or find things that I've done. And so orgdb does that. And the way it works is every org file that I make is indexed, and the results are stored in a SQLITE database. So we can do things like search in headings, full text, images, contacts, hashtags, etc. And I'll walk through how those things happen. All right, the one I use the most often is the headlines. So if I click on orgdb headings here, that's a command that opens up this completion buffer. And let's say I want to search for orgref. Over here you can see it's matching on the file, and these are all headings that belong to one of these files. So if I just press enter here, then it will jump directly to that file and show me what is in the pretty thorough example of refproc. I'll be talking about this file next week. All right, so I use that a lot. We can also look at tags, so I can have anything that starts with a colon. Let's say there I have some things about different things that I might be looking at. Let's say I want to tag review. These are all things that are reviewed. And I can also look at to-do states. Anything that starts with a to-do will be listed in here. So they're pretty easy ways for me to jump around and find things. Now, sometimes there are headings that are special. So a heading that has an email property is considered a contact. And so I have those are done separately. So here is a command that gives me a list of all the contacts that I have, and you can look at what's in these. You can insert links, assign to headings, email them, insert an @ label, etc. And so that allows me to store emails and contacts all over my hard drive. If a heading has an address property, then it's stored as a location. And so I was just playing around with this. These are just different things that places that are stored, and I might want to do something like open them or insert a link to them. I don't use that very often. It was just kind of a fun exercise. I can get to any file. The orgdb files just shows me all of the files that exist. There's lots of them, and they're all over. And recentf is sorted by the last time they were modified. So you can get to files that you might have looked at recently. Org links are easy to do as well. So while I'm indexing, I go through all of the links in a file, and those get stored. And so you get file links, you can get to site links, and this is a way I would probably try to find like all the things that were cited by, let's say this one, SCHUET. These are all documents that have that citation in there. So if you're following your work and you want to find documents you wrote that cite a similar article, then you can use the cites link. And similarly, I can look at finding documents that point to the current file. So these are called backlinks, if you like. So this will work, and here it has two different links that link back to this particular README that I could jump to. So this takes me to here, and here this is just a file link to the README I was just in. Other packages like org-roam do things that are similar to this. I haven't ever been able to like get my head around what that does. So for a while I thought it would be interesting if we could have, you know, patterns like this. So @JohnKitchen might be a Twitter handle. And if you were to tag somebody like this, we could look at this, and then let's say John Kitchen. These are all places where @John Kitchen is tagged. This is the current file that we're in. So it might be an easy way if you were using @labels for some purpose to aggregate sets of files. All right, similarly, we have hashtags. So here's one. Let's look at this. I should be able to type org-db, and here it shows me one file has this hashtag in it, and then all of these other ones you can either match on file names or on the hashtag at the beginning. So you can use this to mark labels here, and I think I should also show you that there is org-db targets maybe. So these just target. This will find the radio targets. So if you had something like this would be the org mode way of making a target. After this file gets saved and indexed, then I'll be able to find this target from anywhere. All right, properties are also indexed. So let's say I want to search a property email that matches. Let's see what comes up with kitchen. Nothing. Probably have to do something more. Email. How about jkitchen@andrew.cmu.edu. This will show me all the headings that have a property with my email address in it. You can see they go back a number of years, 2017 for example. Let's see, I also talked in a video not too long ago about edit marks. Edit marks look like this. This is a comment. And this is a special syntax that I've developed for leaving things like comments, track changes, etc. These all get edited and stored in here, and so you can see different searchable edit marks. So you can jump around to your edit marks all over the place. All right, email addresses. These are things that get embedded in the text. So if I click this, you can see here I have different email addresses. There's a couple of errors, like this is not actually an email address, but it got recognized as one. Similarly here, but it's an okay way to search for things, like if you put someone's email address inside a document. We can also do source block searches. So again, one of the concepts I have in search is that you should limit the scope whenever you can. That limits the amount of work that has to be done to find it and eliminates false positives. Like if you're searching for a word and you know it should be in a source block, you don't want that word in a paragraph. So here, this looks like it is not going to work. So we'll have to skip that one. Images are an interesting one. When I talked in the previous video about Tesseract for optical character recognition, prior to that I thought, oh, I could take all the images in an org file and pipe it through Tesseract and then store the optical character recognition text in a database for searching. So here's a picture here that says zoom, and if I look at this one and type zoom, then you can see that it actually finds the image because it was able to read zoom somewhere in this text. This was super experimental. I thought it was a good idea. You know, in this world of online meetings where you often have to take screenshots of things, or and then want to later be able to find something in the image, it seems like a potentially promising idea. All right, and then finally we have full text search. In addition to all the individual things that get indexed, I can also put the full text search in. So if I look at this, then let's say I search for full text, then you see I don't know, lots of things that that could potentially match in there. This is a giant selection window. Full text is still kind of new, and I don't use it a whole lot, and I'm not sure if there's another, like a better interface to it. But I was kind of inspired to implement it because it seemed like something I might want to be able to search with. Now, naturally, I don't remember all of those commands all the time, so I have a Hydra that gives me, quick one-letter access to all of these things and lets me search through them. And let me chat about some limitations so far. This works. I use this all the time, many times a day, jumping around to find different things. But the database is only updated when you save or close a buffer, and Emacs is not currently active. So it's not a real-time search everything. There is a limitation, and this is a big one. You can't edit files outside of Emacs, including deleting or moving them. If you do that, it won't get into the database because the hook function only works from Emacs on the save buffer or kill buffer hook. So if you're sharing something with Git or Dropbox or Box or anything that is syncing your directory, any new files that get added will not be in your database unless you open them. Then they will get added to it. Now you could set up something that makes that work, like iNotify, or have something that screens your directory paths to find them. But I really don't bother with that. It has been totally adequate that if I have opened a file, then I can see it again. And it's also not really multi-user. It just uses a single SQLITE database that is local, and it doesn't currently work for multiple people to edit files and save into the same database at this time. It would be awesome if it did, but that's going to take running a server and maintaining permissions and things like that. All right, so let's look at OrgDB real quick. There's 3 of them. I'll look at the main one and kind of work through more or less how it's set up. So I use Emacs SQLITE. This is an Emacs interface to SQLITE, and we save it in orgdb.sqlite. There's a list of functions that get called in every buffer that update the database for headlines, links, source blocks, etc. And then the rest of this is not that interesting. There's a bunch of regular expressions for how to match a hashtag. I use this RX macro. Sometimes it feels easier to read than the old-fashioned way, like this is not easy to read. These things compile to these expressions for you. There's a whole setup here, so this is what it looks like to write Emacs Lisp code that creates tables in SQLITE. So here we just create a bunch of tables if they don't exist. It's not super interesting. There's lots of them. And this gets run only when they don't exist here. Then we make sure we're connected, and then the rest of this is really like code for getting a file name. So each file name is stored in its own table, and we need to get the file name ID so that we can link the tables. We have functions to remove a buffer. So if you don't want to buffer a file in the database, you just run this command. And then the rest of them of this is like the functions that get updated in each buffer. So for example, in updating the source blocks, the general pattern is you delete the old entries from the file name, and then we map over the oh, I see, this is probably supposed to be a $sign there. Then you delete the old entries, and then here we map over all the source blocks and insert new entries. So each entry will have a file name, the language, the body, and the position of the block, so you can jump to it. Similarly, for updating keywords, I guess we didn't look at an example there. We delete the old entries associated with keywords in the file, and then here we loop over every keyword and insert new values. And that's more or less how all of these recipes work. They should always start by deleting old stuff and inserting new stuff. And I do that because it's not always possible to just update the entries. If you've taken things out, you need to delete them. And the easiest thing is to just delete them all and then reinsert them. All right, so there's tables, edit marks, email addresses, @ labels, links, headlines. There's a function that updates a buffer, and it does a couple of things. It widens the buffer here, and then checks a couple of things, gets a file name ID, gets a parse tree, and then here we update an MD5 hash of the file so we can tell if it's been changed, and then we loop over every one of those update functions. And then finally at the end we put in the modified time that we did it. All right, then our hook function looks like this. This gets run after in the org mode hook function, and it just adds a file name to the queue, and then after you save it, it runs the hook in a local hook. And then finally, when your Emacs is kind of idle down here, it runs the process queue function. So it just, as you're working, it's your modified files go in the queue, and whenever you're idle, it goes through and processes them all. So it mostly never gets in your way. All right, I do have a way of updating the whole database. So if you decide you're going to move a bunch of files around with the shell commands or something like that, then you just run this orgdb refresh, and it will go through every file and update it. That's pretty time consuming, but it's there if you need it. And here we can have a recursive index of a path where it will walk through some path and add all the new files. So you could run this anytime you want in a Git repo or something like that. And we have a function here to remove entries when the file doesn't exist. So it just loops through all the files and checks if they exist and then cleans them out if they don't. And if we want to reset the whole database, we can clear all the entries. That's just done by deleting from the tables. And then from here down, I think, are the functions that I just showed you. So to get orgdb contacts, first we get the candidates. That's done by doing a select. So we select this information from the headlines interjoined on a bunch of tables to get the full database. Then we get the strings and a plist of candidate properties. We have a whole bunch of functions that become alternate actions, like assigning a contact to a heading, opening a contact, inserting a contact, emailing a contact, making an @ label for a contact, what to do with multiple contacts, a brief key map for the contacts, and eventually we get down to the IV command for orgdb contacts. This just selects a candidate from the candidate pool and provides these actions that I showed you. Locations, not real different. We select a bunch of data from a bunch of joined tables and then loop through all of them to generate the contact or the location strings, and then we use Ivy to work on them. So here I use lambda functions. This is the source blocks search command that didn't work. I'll have to fix that later. Here's the headings. Like all of these work by first selecting a bunch of rows from the table and then building a set of candidates, defining some action functions, and then using Ivy to select from them. So I think these are all like the same idea. I don't think there's anything new. We don't implement a tag search because you can do it from the colon tag name in the heading. Here's our property search. Again, we're just doing a selection to get data, making a set of candidates, and then using Ivy Read from there. Edit marks, backlinks. Backlinks is kind of interesting. There's first we get the name of the buffer, then we get the file name associated with it. Then here we look for file links that match the file that we're in, and I call them potential matches. And then over here we loop through all of them and make sure that we get absolute or relative paths that expand and actually match. So the file links may be relative in the database, and here we find out if they actually match. And then this is just the Hydra. All right, real quick on images. This one is pretty bare bones. Here we create a table. This is the update function. So what we do is get image data. So we map over the parse tree to get all of the links, and then if the link points to a file that is a PNG or JPEG, then we accumulate the link. And then we loop through each one of the image files that we got, and we do a shell command to string where we run tesseract on that image file to get the text, and then we insert into the images table. And then this is the same pattern as before. We do a select here to get rows from the table, generate candidates, use Ivy. And then org-db full text has a separate database for doing the search here. And that's because when I first started this, I think I tried to put all the full text and everything into one database, and I feel like it got too big. So I just have it separated out for now. So we set up a database. The update function here is to, for each file name, delete the old text and insert the new text. So here using FTS5 is the magic that makes this virtual table a full text search table within SQLITE. And then down here is the kind of really naive search approach where we just select the contents and file name from the table full text. So it'd be nice if there was something better. Using a whole document as your Ivy string doesn't seem like the most efficient way to do this, but like I said, this is a relatively new and not heavily used module. All right, so that brings me back to the end of the topic today. So you're getting a preview, and now my QR code generator is going crazy with all the URLs in here. So I'll go ahead and stop here and conclude with that is an overview of how org-db works, and it's something I use all the time. And it's super helpful for being able to find headings, to jump around to contacts and other things, and that's it for today. So thanks for coming, and I'll see you